2.2b is on graphing slope-intercept form. So we want to be able to identify slope and y-intercept in an equation and a graph. We want to be able to graph a linear equation and then write the equation of a line from a graph. So first off, let's review. Remember our y-intercept, it's that starting value. It's the point where your line is crossing the y-axis, and it's always going to look like 0 and then some b value. Slope or rate of change, well, there are 4 different types. Positive, where it's increasing, negative, where it's decreasing, 0, where you have a horizontal line, and undefined, where you have a vertical line. Your slope tells you the angle and direction of the line, right? So how steep it is, or if it's going slowly, and then your direction, is it increasing or decreasing? And then remember, we find it using our rise over run, or we can use our difference of 2 points formula. So we are going to start by graphing. So we have y equals negative 1/3 x plus 4. Notice that this is in our slope-intercept form, y equals mx plus b. So we're going to graph this based on the fact that our m value is our slope and our b value is our y-intercept. All right? So y equals mx plus b. Well, based on this equation, our slope is negative 1/3 and our b value, our y-intercept, is 4. Well, this tells us that a point on this line is the point 0, 4. That's our y-intercept. So let's go ahead and find that. Here's 0 right here in the center, and then here's my y-axis, here's my x-axis. We are going to go up 4. 1, 2, 3, 4. Here's our point 0, 4. Now that we have a point on the graph, you always start with 1 point. Start with 1 point you know is on the graph. And then you can use slope to draw the rest of the line. So we are going to use the slope to draw the rest of the line. Okay, you need at least 2 points in order to be able to draw a line. You can have more points, but you need at least 2 in order to be able to draw it. So our slope is negative 1/3. So our rise is negative 1 and our run is 3. So we are going to go down negative 1 and over 3. Okay, then from that point, we're going to go down negative 1 and over 3. Notice how I don't go back to the original point each time. I just stay where I am. So from this point I found, I'm going to go down negative 1 and over 3. To fill in the back half of my line, I would do the opposite. So I would go up negative 1 and back 3. Up 1 and back 3. Up 1 and back 3. Now this is my line, and then all I have to do is connect my dots, and we have a graph of y equals negative 1/3 x plus 4. Let's go on and try another example. So here we have y equals 2x minus 4. So start off by identifying your slope and your y-intercept. Well, our slope is 2, which we can also write as 2 over 1, and our y-intercept is negative 4. So that tells us we have the point 0, negative 4 on our graph. Here's 0, here is negative 4. Well, since our slope is 2 over 1, that tells us we are going to go up 2 and over 1. Up 2 and over 1. Up 2 over 1. Again, all you need is at least 2 points to draw your graph, but I like to fill all of them in just because then my line is a little more accurate. And when you're graphing, accuracy is everything. So when we're doing this, we're actually going to be using straight edges. Right? Straight edges in order to make that line as straight as possible. And this is our graph. Given the equation, so we have 2x plus 3y equals 12, and we want to find the slope and the y-intercept. In order to find the slope and y-intercept from an equation, it has to be in that slope-intercept form. So notice that 2x plus 3y equals 12 is not in slope-intercept form, so we need to rearrange it so it is. So our job is to get y by itself. So I'm going to subtract 2x from both sides. So we have 3y equals negative 2x plus 12. Well, then we can divide everything by 3. So our equation is y equals negative 2/3 times x plus 4. And now that it's in that slope-intercept form, we can find our slope of negative 2/3, and we can find our y-intercept, positive 4. Okay, but to find it from an equation, it has to be in that slope-intercept form. Let's take a look at this second one. We'll call it letter B. Y equals 10 minus x divided by 5. Well, we do have our y equals, but let's split this up into two distinct terms. So since we're dividing by 5, right, we can just pull this apart into two fractions. So we could write it as 10 divided by 5 minus x divided by 5. Well, 10 divided by 5 is 2, and negative x over 5 we could write as negative 1/5 times x. Okay, and then since it's an equation, we can just swap these around. So we could write this as negative 1/5 x plus 2, and there we have our slope-intercept form. Our slope will be negative 1/5. Our y-intercept is a positive 2. So again, if you are going to use your equation to find the slope and y-intercept, it has to be in that slope-intercept form before you can start. Let's look at a couple more graphs. So here are a couple of special cases. So think back to our 4 different types of slope. These are 2 special cases. So if y equals negative 7, well, we know we have the, notice how for this equation, it's really saying that y equals 0 times x minus 7. Right? And then since we have 0 times x is just 0, that's why we don't write it. So this really has a slope of 0. Right? A slope of 0, which was one of our special cases we talked about. But we do have the y-intercept, so we know that the point 0, negative 7 is on this graph. So let's go ahead and find that point. Negative 4, negative 5, negative 6, negative 7. So we're going to draw the line where y is always equal to negative 7. Okay? Well, here would be the point 1, negative 7. Here's 2, negative 7. Go over 3 and down. Here's 3, negative 7. Right? So our line is going to be a horizontal line passing through 0, negative 7. And that's what will happen anytime you have y equal to some number. We'll get this horizontal line. That's our special case where our slope is 0. We have another special case where when we have x equal to a number. So x equals 2. Notice how this isn't slope-intercept form at all, right? There's no y in there. Okay? So this is our special case of undefined slope. This is always going to be a vertical line. So we're going to find the line where x is always equal to 2. Well, here's the point 2, 0. Right? And then if we have the point 2, 1, here's 2, 2, over 2 and up 3 is 2, 3. So our line where x is always 2 is a vertical line. And again, this is a special case. Anytime you have x equal to some number, it'll end up being a vertical line. All right. Got a couple more examples here. Now would be a good time to pause the video and see if you can graph these by yourself. Well, when y equals half x, notice how we really have this invisible plus 0. So our slope is 1/2, but our y-intercept is just 0, which means our graph is going to pass through the origin. So here's our 0, 0, and then our slope is 1 over 2. So we're going to go up 1 and over 2, up 1 and over 2, up 1 and over 2. And again, I like to fill in my whole graph just because of consistency. Consistency in graphing is really, really key. You notice how my line wasn't quite perfect. That's why you should use a straight edge. So that's our y equals half times x. And then we have one more. Y equals 3/4 times x plus 5. So our slope is 3/4 and our y-intercept is 5. Well, up 1, 2, 3, 4, 5. Then we have a slope of 3 over 4. So we're going to go up 3 and over 4. Up 1, 2, 3 from our y-intercept and over 1, 2, 3, 4. Up 1, 2. Notice we can't go up 3, so we can't actually put another point. We do have 2 points, so we could draw our line, but I'm going to fill in the back half of this line, again, for consistency. And there is our graph. So just to review, we reviewed our slope, we reviewed our y-intercept form. Remember that y-intercept is the point where it crosses the y-axis. And basically, if you do want to graph it or want to find that slope and y-intercept from an equation, you have to have it in that slope-intercept form. Okay? And if you don't remember it yet, memorize M is slope, B is y-intercept.